And we should be good. So, a couple things to get started today. Let's just go ahead and go over the assignment first. To be fair, this exercise 5 is more like a 3-part series, and it's definitely a lot to talk about. First, we're going to make the topography. Second, we're going to put all the model together. And lastly, I'm going to show you how to unfold it and put it to the laser cutter, right? Because who wants to waste all that time sitting there and measuring their model when they can simply unroll something and laser cut it, right? Obviously, we'll be talking about the laser cutter, and it is one of the kind of things that we do, at least in my computer graphics class, that, well, a lot of other teachers don't know how to do. Specifically, I got my master's at Texas Tech University, but I also got my design fabrication certificate in my master's program. So it was a digital design fabrication certificate, which is pretty cool. I get to work with all the machines, right, essentially that are used and applied in architecture. However, one that's been growing in popularity since the 80s is a laser cutter, right? Obviously 3D printing, if we can get to it, it'd be great to get some scale figures eventually for this, but one thing at a time. One thing I would say that is probably the most useful thing that you could have in architecture is being able to make a topography model. Now, don't get me wrong, this is just an example, and no, we're not going to make this many layers and lines. But I do like to show it because, well, it is a possibility, and to be fair, the possibilities are endless, at least in one man's professional opinion. But that being the case, we're going to start off pretty small today and really talk about the couple of ways that we can start manipulating and making topography surfaces from information that we gather either from the internet or even Google Earth. So let's just dive right into it. However, keep in mind, the steps are still pretty vague. So the next exercise is to develop the skills of digital design and fabrication in the context of architecture and to discover the techniques of utilizing the laser cutter for its speed and accuracy in model making. Our first task will be to select a 48 by 48 feet lot of space anywhere in San Antonio. And of course, I've applied also the HTML. However, it is kind of hard to copy. It is recommended that each selection is sloped and or vertically interesting, right? It doesn't make a lot of sense to choose something that's like, just like slightly gonna have some topography, go big or go home. The question of selection is, where should your observation tower go? So yes, almost like a studio project, except you get to decide where your observation tower is gonna go. How many of you guys live next to a park? Really? That bad? Well, if you have a park next to you, you can obviously choose it and maybe even pick a situation where an observation tower you think should go. By all means, this could be potentially used for your portfolio. And to be fair, they don't have to know what is actually a project versus what's not a project. You can easily make this assignment into a pseudo-architectural project that maybe shows off the digital technologies and stuff that you used at SAC. To be fair, at San Antonio College, there is basically a legend, a myth, a rumor, if you will, that we know how to draw at San Antonio College. Now, it has everything to do with the freehand skills that we apply. However, they're a little bit more harsh on us because they're like, well, if you guys are so good at hand drawing, then you guys probably aren't that good at digital drawing. This is where you basically show them both in your portfolio and you go, I got both, right? And usually our students are picked far faster than many others, especially in the transfer situations. Anyway, so step 1, using the command contour. It can be useful if we already have a surface model. However, typically in Studio we are given our site and sometimes the topography from a land surveyor. After we have traced and created a topo model, we can now prepare the model to be sliced and printed via laser cutter. Step 2, we can also ready the model for our selected observation towers using Boolean difference. Pretty vague, if you ask me. Step 3, then we can add our vertical circulation and refine the model. Obviously, we'll add the stairs last. And refine the model as necessary and dial in the unit as is and the perfection representation of. And it looks like I left out a word. Step 4, lastly, we must prepare files for laser cutting using unroll surface and or make 2D. So as you can see, pretty vague, but clearly during those steps, kind of calling out obviously one of the major commands that we'll use in each step. First one being, of course, contour, and in the making of our topography model. So you'll see we have a couple things that we're eventually going to get to, which is essentially a model. Yes, a model is going to be required of this project, and good news, it can be entirely laser cut. It doesn't even have to be hand cut. To be fair, hand cutting looks better though. But there are ways that we can use the laser cutter in order to trick someone. They don't have to know if it's handmade or not. In fact, if we burn or if we take off all the burn lines, they would have no idea. Now, don't get me wrong, they'll expect seeing absolute perfection, that they'll be like, wait a minute, I don't think this was handmade, right? But more often than not, a technique that I learned at Texas Tech, being the laser cutter technician myself, oh man, I accidentally touched my HDMI cord. This is not the greatest HDMI cord. I miss our old HDMI cord. Hopefully the recording didn't stop. I can't promise that there's going to be any cutouts, but let's wait for it to come back. This is why you don't touch the cord. Anyway, we're back. However, just to continue explaining, obviously we'll make a topography model, which is mostly what we'll focus on part 1 today. Obviously vertical circulation basswood, columns basswood dowels, and volumes horizontal chip or museum board eventually. But we definitely have our standards for model making, and we use the exact same materials because, well, they're easy to laser cut as well, and they're relatively inexpensive. However, for the schedule, of course, this week, exercise 4 has been pushed to Thursday. And keep in mind, it is only a Miro pinup. It's not, you don't have to print out the stairs. I do want to see them though, right? Just so that we can take a look at the graphics. However, by next class, and I would say try to get here by 8:15, guys, because we're going to go right to the laser cutter, just because there's a next class in there at like, I believe 10. So we can't just like walk in there and be like, hey guys, laser cutter. So we are going to go over the laser cutter in the morning, so it would make a lot of sense to be on time. Anyway, obviously by week 9, which is next week, yeah, that, by the way, we've hit 50% of this class and all of our courses. It's almost over, right? We're halfway there. However, by week 9, we'll introduce exercise 6, which is mostly Photoshop, and I'm going to be introducing the Wacom tablets as well. So we'll get some more familiarity. However, exercise 5 really isn't due until next Thursday. And to be fair, it's actually a portion of it. Obviously, the topography portion is what's due next Thursday. So obviously 2 weeks right there. But let's go ahead and get started. And where we left off last time was obviously my abstract model. Congratulations, guys, for completing assignment 3. I know it was difficult, but you made it. You made 3 models, and honestly, a lot of them really fantastic results. However, I ended up with this for today, so I'm going to go ahead and make a copy of it. Just in case I mess it up, I can always go back to the original and go ahead and move some things out of the way or hide them, right? Because I don't necessarily need all that anymore. Now, one of the things that you can do is, of course, in your separate file with your stairs, and here's one that I made, I think actually during the summer, I can't remember. But I was, of course, explaining exercise 4. In my case, I'm going to go with the one that's already perfectly in the X and Y direction. So keep in mind, if you moved yours, again, it's very useful to make a copy before you do things. I can't tell you how much time I saved just knowing that, hey, I'm going to manipulate this model. I should make a copy. Again, I hope that's always in the back of your mind. But there are 2 ways we can actually import this. So I can either select the entire thing, do Command-C, and literally copy and paste it. So when I hit paste, quite literally it's going to paste it in the exact same coordinate of my previous model. Now don't get me wrong, that's probably the easiest way, and what's nice about that is it's also going to paste in the layers that come in. Another way to officially do it is to actually go to File, Import, and make sure that you import your Rhino model. Now in my case, I'm not going to do that because, well, to be fair, I've got a lot of files. But that would be really the more professional way, is to import it. What's nice about that is you can really control the amount of layers that come in. You can actually select which layers. Say you had 1,000 layers, you can be like, I only want these 5, and that's pretty nice too. To be fair, we'll use the copy clipboard method today just because, well, it's a relatively small model. That way we kind of have that on the side, and we can get ready to basically think about our topography. Now, one of the first things that it said to do was actually select a 48 by 48 piece of land anywhere in San Antonio. So let's go ahead and go to San Antonio, not Africa, and let's check out some locations. Now, for the sake of tutorial, obviously you don't have to pick the exact same place that I pick, but in my case, one of my tried and true traditions is to pick one of the hilliest spots in San Pedro Springs Park. Also, I just feel like it'd be really cool to have an observation tower here, considering there's a sidewalk that essentially goes nowhere, and there's already stairs there that just begging for an observation tower. But as you can see, there's not a whole lot of topography lines. To be fair, there's a couple ways that we can do this. We can just look at it. To be fair, I can't tell you how many times, even at San Antonio College, I would just kind of fake it, especially eventually once you start understanding the way levels work. And if you don't yet, obviously, we're going to get a little bit more attuned to it in this tutorial. However, there is a couple of ways to obtain this surface. The first one being the hydrology and contours map. So there's that one that I linked actually to the assignment page today. However, if you just type in contours and hydrology San Antonio, it is definitely the first one that comes up. So in my case, we know the map pretty well, and we can go directly to San Pedro Springs Park. And you'll see in these orange lines the topography. Now, to be fair, it's a pretty interesting location, but I only need 48 by 48 feet, and well, it only zooms in so much, right? So that'll have to do for today. In my case, I do want to take a screenshot of that, and I do want to get a healthy portion. That way I do have other things to line up to. So in my case, that looks pretty good. I'm going to take that screenshot and save it for later. In my case here, I do want a screenshot to line up with, and after all, I do want this to be to scale. Yes, for the first time, guys, we are showing how easy it is to make things to scale in the digital realm. Arguably, once you get the hang of it, it is 1,000 times easier than, I would say, analog or messing around with scales any day. To be fair, you need to know how to do both and to interchange them. But in our case, that is why I introduce it a little bit later in our assignments. But that being the case, this is relatively the same area. And again, I do want to get a larger swath of what I actually need, but I do need a single measurement, right? To be fair, it doesn't really matter what measurement I take here, as long as it's one that I know and is accurate. To be fair, one of the best things that we can do is just go to the site with a tape measure and measure it. For instance, a sidewalk or a street, or honestly, the larger length that you get, the more accurate your drawing will be. To be absolutely honest with you, the way that Google Images works is actually a high altitude balloon. It basically takes pictures and photo merges them together. It's not exactly perfectly accurate. And if you guys were there for the demonstration with Aaron Ellis, you guys saw the photogrammetry, right? How they take multiple shots, thousands of shots, and turn it into a digital model. What do you think Google Earth is? It's thousands and thousands of images now being reinterpreted using photogrammetry in order to make a digital model. To be fair, that's why this tree just looks like broccoli, because, well, it's not enough pictures to really get every single bit of detail for that model. Anyway, just wanted to explain it because it's worth explaining. So let's get a measurement. Doesn't really matter where, as long as it's within the screenshot that I'm going to take. But in my case, I am going to use 48 feet, so I might as well get 48 feet out of it. By default, it's in meters, so make sure that you don't use meters, otherwise you'll have to convert. And to be fair, I forget where I can change the meters. Does anybody remember? Top tabs. It's usually somewhere right here. I'm not sure. It's usually like right there. Right click, no.
Or the 3 dots.
3 dots, 3 dots. Looking for the 3 dots. Obviously, I guess we can convert our units for today for the sake of time, but there should be an option here. There usually is. However, to be fair, I can show you another feature and grab from this one as well. That is the browser version of Google Earth Pro. However, I do appreciate the Google Earth Pro standard version. I think it works a little bit better. Get out of here. Now if I can find San Antonio, that looks like San Antonio. It doesn't load very well at school, but I will show you why I do appreciate it and like it better. One of the first things that you can do, especially, I think you can do it now in the online version, but you can go back in time, which is, I've shown before and is definitely awesome, especially for studio situations where I'm really trying to show maybe even a sequence of time. Maybe not necessarily important for today, but another thing that I really like is the measuring tool. Obviously for good reason. It has its units, very easy to find, and it defaults into feet, which is really cool too. But I can also zoom in a lot more in Google Earth Pro. It's just a higher fidelity image. And to be fair, I do like the line method rather than kind of the bulbs that come about in the online version. Either way, it's not a big deal which one you use. But in my case, I do want to make sure that I get a measurement, so I'm going to go with 48 feet. In my case, I'm going to try and get as close as humanly possible, and 48.04 is pretty good, so I'm going to take it and save. We'll press OK. And again, I just want to take that screenshot. After all, I'm just going to go ahead and end up tracing it in Rhino anyway. So again, I'm going to take that screenshot. Doesn't really matter how big a swath, but I do want to make sure I get my 48 by 48. And let's go ahead and take those two. And to be fair, this takes up a lot of memory, especially while screen recording, so I'm going to quit that. Don't save. So now that we have our topography map and our other piece, we can actually splice those and put them together in this image. Now to be fair, I've got a lot of layers going on. Obviously this is not the way that you want to organize your piece, but in my case I do want to make something that's now called topography. Sweet. Oh, didn't even type. Sweet. Classic green, why not? I mean, it is topography. And let's get our extract model out of the way for a second. And we'll put them over there. Let's go ahead and make a 48 by 48 rectangle, because why not? 48 feet by 48 feet. And some of you guys were actually realizing that you had like gigantic scales and different units, but there was nothing to fear. We could scale the entire thing at a certain distance at any given time. However, it's always good to make sure and do DIM and check your dimensions, right? Of course, 48 units is definitely 48 feet, so we are in the clear. I'm going to go ahead and type in picture and take in those two pictures. I think I've done that before, but honestly I can't remember if I have or haven't. And to be fair, I think that was from yesterday. It's in downloads, screenshots, and recordings, and of course the two pictures that I want to take. I do think I have to take them one at a time, but that's okay. Let's go ahead and go with our measurement first. Not too shabby, and I can actually see it pretty well. You might want to slow this part down, right? So one of the first, and really honestly I end up doing it in every single project, is making something one-to-one in the digital realm. I can't express this enough. We don't make things at different scales in the digital realm. That would be silly. Can you imagine in Studio you'd have a 1/8 model, a 1/50 model, you'd have a 1/4 model, you'd have a 1/32 model. That doesn't make any sense, right? Having to make a new model every single time you want a different scale, right? We make one model and we make it to true scale. What is true scale, guys? It actually has a scale. What's it called? 1-to-1, right? One in reality, one in the digital realm, right? So let's go ahead and establish that, since that's going to be 48 feet. And yes, in Google Earth, that represents 48 feet or 48.04 feet, right? So I can actually be very specific, but for the sake of today, we're going to claim that it's 48 feet exactly. In my case, I'm going to scale it. So type scale. It's going to ask for my base image. So one thing I left out is, well, we want the end of our line to actually match up with the end of this rectangle. We'll take the image itself, scale it. It's going to ask for a base point, so that is the same point as our line and our reference point. And in my case, it's having a hard time finding the end point. So let me escape. Let's try that again. Find the end point. Please. This is what happens when you're screen recording. Please find it. Let's see if we can get it in a different view. I might just be able to take it a little bit lower, and that might be why it's doing that too. Scale. There we go. I would definitely recommend doing it in your top view. It's a little easier to look at, but we'll take our base point, and now it's going to ask for a reference point. In my case, the reference point is the other side of this 48 feet. That is alignment with the previous line. So, I mean, don't get me wrong, it's inaccurate, right, down to the pixel. So usually I just pick somewhere pretty close. You can kind of see that there's a very red spot usually, and kind of the end kind of fuzzed out. Again, I usually just pick the middle. To be fair, we're at a very microscopic scale now. So zooming out, now it's going to go, hey, where do you want that 48-foot line to be? Well, I want it to match with 48 feet. Voila, just like that. I have a scaled model that fits perfectly. And to be fair, now I can move this rectangle around And I have 48 feet everywhere, right? Obviously. So in my case, I'm going to choose maybe this part of my piece, maybe a bit of the stair in there. That's looking pretty good. And to be fair, I do need the other topography piece. It'll be a lot easier to line up that drawing, especially if I have some more stuff in it. So let's type in picture again. And let's get the other piece. And fake it till we make it. Yeah, that looks pretty close. And as you can see, I can't really see through these. So again, I will go to properties. I can go to the little, kind of the same as the material that we did last time. And we can give it a little bit of transparency. That way it's a little bit easier to see and easier to trace. So something that Photoshop does pretty well. And to be fair, these aren't going to line up perfectly, but we can get them actually pretty close. So make sure I hold shift to of course make things bigger. However, to be fair, I'm going to line it up to the street and just kind of hope for the best. To be fair, this is exactly what I would do in studio as well. However, the more accurate you are, the better you can get. And to be fair, there are some telltale signs of the topography and what it aligns with. For instance, you can kind of see it on the streets. You can see the green layer that's kind of representing the park area. And to be fair, I'm trying to just line it up to kind of the interesting anomalies I see there. That's looking pretty close. To be fair, it is just for the sake of a project like this. Let's go a little bit bigger. Fake it till you make it. That's looking pretty good, at least for today. And it looks like we got a lot of our topography there, showing that hill that we saw in Google Earth Pro. So that's looking pretty good. Last but not least, let's trim it up. That way my RAM doesn't have to do all that. So trim and get rid of the two images, and voila. That's really all we need for this 48 by 48 topography model. Now, as you can see, I definitely have the topography, but it's not really three-dimensional. To be fair, I could use this now to print at 2D, right? I can literally just put this to Illustrator, scale it up now, scale it down, and I can scale my entire drawing, right? Just like that. Which we'll go over when we go over printing this to scale as well. But for today, let's go over making actually a topography surface. Now, to be fair, there's a couple of ways like I mentioned. The first way that we're going over is really the cardboard method, or at least that's what I like to call it, because, well, typically we stack layers of cardboard, and each of those cardboard represents a foot, right? Which, if we know anything about topography, each of these lines represents an elevation level. Essentially another plate stacked on another plate. Certain amount removed starts to reveal that sloped area, right? In our case, we can definitely tell that it's sloped. However, there's no real indication of it sloping up or down. So again, you might need to look at Google Earth, look at that map, or look at it three-dimensionally and go, oh, it's sloping down this way. Otherwise, well, at least compared to the shot, there's no real way of telling. So let's get a little bit bigger, and let's close actually my other Rhino piece as well, my bad. I actually have a few open. That's definitely going to stop me too. But yeah, let's maximize on our real estate space. Looking pretty good. So the next thing that we have to do is, yes, we have to trace this. And luckily it's not too many lines. And for the sake of tutorial today, it is just one of the methods that we can use. So I'm going to make a copy because why not? And let's go ahead and make a new layer and call it Topo Lines. Sweet. I'll make it a darker green today. Why not? I'm going to actually lock my other layer and, well, maybe set this one to topography itself. So change object layer, and I can go ahead and lock it. Why lock it? Well, I don't accidentally want my O-snap to kind of lock onto it. And the next thing I want to use is actually my curve tool, my topography, and double click on topography lines. Now, to be fair, if you have the Wacom, this is actually super easy. You just trace it, quite literally. If you have a ballpoint mouse like I have today, well, you can kind of fake it till you make it. To be fair, that might be actually kind of hard to see. So let's change that maybe to like an orange today. Well, I don't want to, man, we're running out of good colors. Let's go with magenta. That one's pretty easy to see compared to the orange and the green that's going on. However, I want you to notice that I'm tracing it kind of outside the box. This will become important when we start to loft these surfaces because, well, we need something that actually says it's ended, right? For the sake of tutorial though, I'm going to kind of just fake it till I make it. Obviously in your case, you do want to trace every single line, right? And to be fair, I kind of use the line as a guideline, and nobody's ever going to sit there and go, hey, I think your topography lines are ever so off, right? I mean, there's arguably no way to tell. You'll also notice the direction that I'm going. I'm going to kind of this left to right. Keep in mind that direction really does become important when we start to loft these lines together. So you'll notice I keep starting off in this corner. I don't just go back and forth. However, for the sake of tutorial today, I'm only going to do a couple of these lines. That way, again, what do you do with that? Well, you fake it till you make it. Basically, that's two lines really close to each other. And you'll see what I mean by that. So when you draw your next line. But as you can see, we get a very nice, clear, and crisp line. Another way to do this is just really a polygonal line tool. And you can get kind of more of a choppy, kind of Mario 64, if you will, look. They call it a polygonal look. Bless you. But that's looking pretty good. I'm going to go ahead and end it with getting some of my layers at the top. Again, I'm not trying to be here all day. But really for the sake of tutorial, as you can see, you got to trace each line of your topography. To be fair, there are some unique ways such as CAD Mapper, but often I would say it's not really that great. And to be fair, there's a lot of inaccuracies with it, so I wouldn't lean on it so much for Studio, but a lot do. And we might as well get the middle one in there, why not? Feeling like Bob Ross today. But as you can see, it's pretty heavily pixelated because of the fidelity of the image. And to be fair, well, there's nothing we can do. I mean, I guess we could email the contours and hydrology map, but they're not going to be able to do much either. But that's looking pretty good. Definitely not bad. We got our layers, and definitely say we got all of our topography. I'm going to go ahead and unlock that piece and get rid of the pieces that I don't need. That's looking pretty good. However, for the sake of what I at least want to show you today, I want to show you two different methods. Bless you. Actually, maybe arguably like three different methods. So the first one I'm titling the cardboard method. So let's maybe just call it out. Cardboard method. Woo. Cardboard method. Sweet. And we'll make it a little bigger for dramatic effect. The next one we have is really a surface method. So really I'm kind of just putting these out here to kind of also remind myself. You don't actually have to do this part, but it does help. I mean, anytime you can organize yourself, guys, seriously, you're not helping your present self maybe, but you're definitely helping your future self when you accidentally have to open this model 5 years down the road because, oh man, I need to make a Make 2D drawing real quick for my portfolio, and the thing is just chaos. And you sit there and use a couple of your hours of time rather than actually just going, wow, look, everything's labeled. There's the one I need. So again, the time you put into it today is, and definitely will, at least in my experience, helps you tomorrow. So anyway, cardboard method, let's go over it because, well, I would say it does take a little bit longer, but definitely arguably not bad. And probably at least the easiest to conceptualize. Now, by default, we have everything pretty flat. Right, and to be fair, it's a lot easier to draw this first in kind of a flat position and then, well, stack them, right, like you would stacking cardboard. So the first thing that we need to do is actually trim it. So TRIM, and in my case, I only need that extension for the lofting. To be fair, in the cardboard method, I guess you don't really have to go above the line. But that's looking pretty good, pretty solid, and we'll hit enter. But we need each piece, right? And to be fair, we need a certain amount of that piece. For instance, that bottom piece is maybe our base. The next piece, well, do I need this side or do I need this side, guys? What do you think? One's in the chat for left, two's in the chat for right. Isn't that what the kiddos are saying these days? Anyway. Obviously, I'm showing my age. But in our case, we do need the right because that's the piece that we actually want to cut out. This is the piece that we're actually trying to cut off, right? So we don't want to keep that part. So in our case, I'm going to use my polygonal lasso tool. Or sorry, that's Photoshop. My polyline tool. And I do want my intersection point, so make sure that your intersection is activated. In my case, nothing will happen because you're screen recording. So let's try again. For some reason, if I just keep doing the command over and over again, it somehow works, but that obviously shouldn't be a problem for you. But in my case, I really want to draw the rest of it, but why work harder when I don't have to, right? Obviously make that piece, and join them. And yes, we will need to do that for each piece. To be fair, some people like to hide this as they go, especially if you have a very complex topography model, right? Some of you guys just built a site model and you realize that how many people you actually even needed to cut all this topography. If you had to keep track of 86 pieces, you know, you might lose track of one, right? But let's continue, same tool, go for that intersection. In my case, let it find it. But then use the pieces you already have, right? Enter. I'll take that piece and put them together and join them. And again, hide. Work on the next piece. And to be fair, I will do this for the sake of tutorial, just because it doesn't really take too long. And to be fair, this is honestly the way that I learned as well. How it was taught to me by another Texas Tech student. He goes, dude, just use the cardboard method. I'm like, what are you talking about? So we'll hide it. Again, next one. Don't worry, hang in there. This is the ASMR style of the topography. Can you imagine just making a bunch of money just like tracing topography? There's somebody out there doing it. You'd be surprised how many people listen to those and how many people have tinnitus. But let's get all of our cardboard layers, and as you can see, yes, it is tedious. The good news is you only have to do it once for any scale, so there is some good news. Join, hide, and then lastly, these two, obviously I don't have to go all the way around anymore. I'm still going to that connection piece. However, it still can be a question, right? Just keep in mind which piece you actually want to keep, because theoretically I could do this. I can go around this way, right? Or I can simply just cut off the piece, right? So again, and make sure you get the right lines when you join. Hide. And same thing. Come on, screen share. There we go. Obviously, you shouldn't have to command so many times. But in my case, I'm going to type in show and get all those lines back. And I think I brought everything else back, so I'm going to hide that as well. Oh God, what have I done? See, this is why I don't just turn on things or move things. It's okay, we can save it. That was my copy, so we're okay. But this guy, I don't even need you anymore. Actually, that was my copy. You're good. Get out of here. We don't need you. This is why you always have a copy. Because you never know when you're going to mess up. Anyway, we'll get rid of that copy because we already have a copy, and we'll hide that. Sweet. Anyway, I like things to look pretty. So we'll go back to perspective, and we see that we have all of our cut lines. To be honest with you, maybe you accidentally traced wrong. And I will say, it does happen, especially when you're tracing topography and you have multiple levels going on. Again, this is why I kind of did this all flat first, and then of course you'll see in the next step, then I move it. So in our case, you can close curves. So what if that's accidentally open? What do I mean by this? Maybe I can take this point. Dang it, it's connected. Sometimes you accidentally have an open curve. What you can do is actually type close curve, and if it's accidentally open and you're extruding, I think we went over this actually in the stairs, but I've noticed it actually a lot in our students, guys. You guys are extruding stuff and you're noticing it's hollow still. That's usually because there's not a closed curve, right? So be very careful. But again, there's actually a command called close curve, and close it before you extrude it. Again, close it before you extrude it, right? You should be saying those words before bed. No, I'm just kidding. But in our case, let's go ahead and build the topography. And each of those layers we know is going to be 1 foot. So of course I'm going to extrude it. This will be my base. And it'll be 12 inches or 1 foot, right? So I can type in 1 foot, enter. Voila, we have our base layer. To be fair, that basically went up, right, because I typed in 1 foot. Now if I type in -1 foot, equally it actually goes down. So if I type in -1, it'll actually go, well, it should have gone down. Dang it, Why didn't it go down? Anyway, maybe it doesn't. Or maybe I'm doing something wrong. But I like to actually do it in a down method and actually kind of grow it as I keep going. So I'll take the next line. Again, extrude. 1 foot or 12 inches. Awesome. I'm going to take both of those and move it down. I'll take a point that I know and go back down. Again, there's my next line. Cardboard method, right? Extrude curve. Again, in my case, 12 inches. Awesome. I'll take all 3 layers, move it down. In my case, you shouldn't have all these issues with your O-snap, but I do. There we go. And again, so on and so forth. But you'll essentially take each closed curve and extrude them. As you can see, now it went down. Not quite sure why it did that. So let's edit undo. Extrude. Oh, I know why. There we go. It goes to the direction of your cursor, by the way. So it didn't matter whether I hit -1 or 1. It considered that just 1 unit, at least in terms of distance. Now, usually when you're drawing in 2D, it does go by distance. So interesting. I learn something new every day. Again, I can select a point I know to a point I know. So again, I don't necessarily have to like use the next layer. I can just always kind of go with the next point that I know. Next layer, extrude. Let's go 12 inches. Awesome. Again, I'm going to take each one. I'm basically just holding shift. And I'm keeping my lines there as well, just because I don't like to move those. Ah, come on. There we go. Only a few layers left. Hang in there. Doing this as fast as I can. Come on. Come on. I don't know why it's doing that today. So badly. Edit, redo, move. And it's probably because I'm screen recording. There we go. But again, as you can see, we're starting to really build up that model and potentially just making a 3-dimensional version of what we would potentially actually cut in the laser cutter. Come on, extrude. Come on. Oh my gosh. I guess I could just take it and move it up 12 inches too. Don't get me wrong, there's more ways. I hate the saying, but it really is true. There's like more ways to skin a cat than one. I don't know why that became a saying, but it is. Dark sayings. Welcome to Brett's class. Anyway. But there are multiple ways to do, of course, the exact same thing. And to be fair, some people like it one way versus the other. It really is a lot of preference. But in my case, let's move that down. To be fair, I'm doing the exact same thing that I did in that move. It's just arguably a few more steps. And my last layer, last but not least, extrude. And now it works at the end, okay. But fair enough. And what's nice about that is it actually looks pretty good in render as well, right? And really starts to portray the slopeness. Don't get me wrong, mine should actually be a lot more sloped. There should be a lot more layers, right? But for the sake of tutorial, definitely on the right track. And they align up pretty well to where it basically looks like a finished box anyway. To be fair, there's a few things that we can do with that I can use to kind of show off before I go over this part. So let's make a copy, because I may want to keep that one, especially for laser cutting, because it's already isolated pieces, and why not? But another thing that I can do is actually put them together, especially if I was 3D printing. So again, I can take all those pieces and Boolean union, and just like that, I have a whole new surface. Yes. Oh, forgot that one. Say that again? Sure. Let me add this one though. Boolean union. Keep in mind, it won't be a mesh, it'll be a poly surface. Valid poly surface. What is that? Oh, just a rendered mesh. Yeah, that's not the same as a mesh. This is where it actually tells you what the geometry is. In our case, it's a poly surface. In your case, and this is a specific question that he had, you can type in mesh, and you can turn it into a triangulated mess. Right? So don't get me wrong, that's a telltale sign of a mesh, right? However, you can mesh Boolean as well. So if you type in mesh boo, you can see that we have the same operations that only work for meshes. Now that's a game changer, because honestly, when I was going to school, that was not the case. You had to flip and flop between meshes and poly surfaces. What I'm trying to say is, I mean, it's good to be aware of both. To be fair, 3D printers, they only print meshes. They don't print poly surfaces. So don't get me wrong, eventually you'll run into meshes, right? Especially if you ever design characters or anything like this and you want something that's a little bit more fluid. It doesn't usually happen a lot in architecture, to be completely honest with you, unless there's 3D printing. Because to be fair, we don't even need meshes for laser cutting. But definitely a good question. But what's nice is now we do have this piece that potentially I could turn into a mesh and 3D print. Another thing that's kind of nice about this is I have a manipulatable mesh. That's pretty interesting. And I can manipulate all together. To be fair, that's not exactly what I need in Studio, but just to kind of explain what we can do with this piece. The next method that we have is actually more like a topography surface, and it's more like a lofted surface. To be fair, sometimes it works, sometimes it doesn't. And to be fair also, we need a few more things. So in my case, I'm going to move this out of the way and see if I can actually use my previous lines just to save some time. Because essentially I do need some closed curves again. So I'm going to move that out of the way. And did I keep them flat? Ah, man, I kept them flat, but that's okay, because I still have them all together. And what's nice about this, at least, is I can go one at a time and of course move it. Now in my case, kind of want those out of the way, so I'll push them over there. Sweet. So I'll take one line at a time, or I can work smarter, I guess. We'll leave that one at 0 and move these down. So type in move. Ooh. Move. And we'll go down 12 inches. Next line. Move. And go down 12 inches. Next line. So on and so forth. Probably messed up mine, but that's okay. We'll fake it till we make it for today's tutorial. To be fair, there's another thing that you can do where you knock out 2 birds with 1 stone. I remember thinking this was cool when I first figured it out. But we can take that almost like a wireframe. You guys see that? Now we just moved each layer 1 foot away from each other. But funny enough, especially now in Rhino 8, you can take every single line, extrude 12 inches, and get the exact same model. So you can do things, again, there's more than one way to skin a cat, as they say. However, let's take our base model and let's just kind of fake it till we make it for today. But more or less, we kind of have a wireframe that, well, we can work with this as well. I mean, don't get me wrong, that's eventually what we need. Not necessarily spatial for the laser cutter, but we do need some flat, closed curves. In my case, though, I can lock these now and turn it actually into a surface. Now, this is where, remember those little arrows that we saw? This is where things actually do start to become important. Those arrows basically represent a direction, and you definitely don't want one arrow facing one way and one arrow facing the other way. However, we also want them relatively close to each other, right? So, to be fair, I clicked too soon. Let's try that again. Loft. There we go. But we can actually take some of these points. If I could click on it easier. Make sure you click on that exact point. Oh my gosh. It might not work today with my screen recording. That's okay. Normally you can move the points, but if you're screen recording, I guess you cannot. But nicely enough, when you move those around, you can actually control and make kind of a semi surface. To be fair, with a loft, there's a lot of options, such as loose, tight, straight sections, and uniform, right? And to be fair, you get a lot of different variations. In our case, I think normal is going to give us, honestly, the best result there. So go ahead and loft. And let's take a look at that in rendered. Definitely not bad, but as you can see, some definitely crazy anomalies. So maybe not exactly useful yet. Let's maybe try our other methods. However, if I was doing, say, like a render for, say, Lumion or something, I would definitely probably use some sort of lofting method. But what's kind of nice is we can take a few. Now, to be fair, I should do this a little bit more accurately. But for the sake of tutorial, I'm just kind of lifting it up, quote unquote, a foot, just to kind of show off that we can still take these single lines and loft them as well. Now, don't get me wrong, some pretty wild results, especially if the line is actually flipped. So again, maybe not entirely useful yet, but definitely useful in situations where, say, I don't have actually the topo surface. I can actually go from a surface back into a topography. So this is what I mean by that. So in our case, I do have this Y shape, and that's definitely why it's not working, right? If it was a little bit more continuous, just one slope, it'd probably work in a loft scenario. However, we can also go the other way around. So for instance, let's say I have a typical surface. So in my case, please lock on, there we go. Let's say I just had that surface, and in my case, I'm gonna hit function F10. That way I get some points. Surface point and surface point. And let's say I had something pretty wild, right? Let's say it was maybe something more like that. And I basically have a crazy topography surface. Oop, emoji. We can actually go the other way around as well. So if we contour it, we can choose the base point, which is going to be here for today. It's going to ask me which direction I want to go, and I definitely want to go in the Z direction. So basically up and down is the direction I want to go. And I want it to be a distance of 1 foot. So that's looking pretty sweet. I press enter and voila, it made the topography lines the other way from the surface. Now that's really helpful, especially if it's in a fictitious situation and I make the surface first, bam, I can make the cardboard method or potentially laser cut this pretty easily, right? There's all my layers, just like that. And to be fair, the more that I actually change this, actually I can do it again. And it's going to produce the lines again. Oh, as long as you choose the right direction. And you could choose as many topography lines as you want. To be fair, I think of Caden's project in D4 last time where he was trying to do this crazy surface, and I taught him contour, and he just never kind of used it. But he could have made that a lot easier on himself by actually just making it a surface first, and of course contouring it and going the opposite direction. So I do like to show my students that. I don't even show my D4 or my Graphics 3 usually these kinds of techniques, but you can actually go the other way around. Lastly, with this method, what's nice is, well, there are some ways. So if you go to terrain to STL, so terrain to the number 2 STL, there's this website right here. You can actually take any spot on Google Earth and you can turn it into a surface as long as it loads on the school computer. We can say go to Rockport. No, I'm just kidding. I don't know where Rockport is. We'll go to the only place that exists, San Antonio, Texas. We'll get roughly close. I mean, don't get me wrong, it only zooms in so far as well. Oh, wow, it actually zooms in a little farther these days. Dang. Oh, wait, I forgot. The bounding box is what we're centered to view. So that's the model it's going to give us. And as you can see, it's a very large model. We can get some more, obviously it goes by the degrees of longitude and latitude. So let's shrink that down as much as possible, and you can move it. But to be fair, it does get the entire park. One thing I would suggest is putting your selection actually in a corner of something. It's a lot easier to find, right? So if I was trying to get this exact portion of my area, I'd probably do something more like that. That way, at least I know it's in this general vicinity of the model itself. However, then I generate the model, download, downloads, save. And we'll go ahead and import this time because that's the correct method. Import, downloads. In my case, it came in as a zip file, so it's compressed, and I just need to double click on it on the Mac. If you do have Windows, you might have to actually install WinRAR, WinRAR. You probably have it on your computer by default. But we'll take that STL file, which is a stereolithographic file, which is actually what you use to 3D print. And in my case, I'll take that STL. I think I accidentally put it in there twice. Usually this by default is fine. And import. And as you can see, there is our little corner. So we can chop it out with wire cut and of course contour it up, right? So don't get me wrong, this is a mesh, right? So if you type in what, it is going to say a valid mesh. How do I go the other way around? Is there a way? There is. We can go mesh to NURB, which is what it's called. So we can go back to a poly surface. It also is very draining on the computer. Now, if you're on the school computer, it should be a breeze, right? And if you have a computer like my own, it's not too shabby either, especially when it comes to calculations. Let's type in what again, and make sure that it's a valid, okay, that's the mesh. Try again. Valid poly surface. So again, it still looks triangulated. Don't be fooled. They look very close, but one is, of course, a different coating. One can be wire cut and one cannot. The mesh cannot, so let's get rid of it. In my case, I'm going to take that 48 by 48. So I can take that, why do that all over again? Copy that one. I'm going to take the same section and realize, oh crap, it's already too small. And that's because, well, probably by default, this was in millimeters. So I do want to times it by 12, or fake it till I make it. And for today's sake of tutorial, obviously it's going to choose 1,000 feet by, I think, 1,200 feet, but for the sake of tutorial, let's just call that the correct size. And let's take our original piece and wire cut that out. So wire cut this piece. Go all the way through in the Z direction. Sweet. Nice. We'll get rid of that piece and we'll keep this one. It's actually looking pretty sweet, but I kind of want to go for a little bit more topography there. You guys see that? It does come in at a different scale. So obviously we will want to, if you do use this method, and this is much more of like a studio situation. Obviously you won't need it for this project because we're just selecting something in San Antonio. However, not every place has topography maps that are in a website. Maybe your project's in Spain, maybe your project's in Houston or in the middle of nowhere, Texas, where there is no topography lines being measured. So you might have to use this method sometime in studio. However, once we're done with that, I can contour it again. I can choose the direction. So in my case, make sure you choose the right direction. And to be fair, we could do that in any location here. I'm going to choose 1 foot and make sure it's in the right direction. Nice. And again, I can get some topography maps for these situations. I think I went a little too big. Let's try that again. 12 inches. Sweet. Second distance point. Let's go 12 inches. There we go. So obviously I can get the topography lines via the other way around as well. Obviously I don't need all these, so let's get rid of those. And similarly, I have the exact same thing that I need for a construction model, right? Now for today, just to recap, we went over quite a few things. Obviously we got some models situated, so we finished up our stairs, we finished up and selected our abstract project, and we started going over the topography. In part 2, we'll actually start putting this together, more likely Thursday. right? Like I said, this is more like a honestly 4-part series. I'll probably even spend 2 parts on just the laser cutting and dicing some things up. Next class, we'll actually talk about first the laser cutter. So I do want to actually have some pieces ready for that laser cutter on Thursday. So let's maybe do that first. After all, actually, well, I can't, because I do need to cut some holes into this because I'm potentially putting some columns in. So I do want to cut those out and make it more like a puzzle piece. So I'll leave off that conversation for today. We'll introduce the laser cutter and we'll cut a few things on Thursday. And of course continue with part 2 and basically putting this model together. However, to recap, we went over the cardboard method. We went over a surface method, which is basically surface first and grabbing the contours. Cardboard method, basically the tried and true way. And we went over a little bit of lofting, which you saw didn't work. Again, I like to kind of show some things that do work and don't work because, well, all these tools might not apply to one situation, whereas they might apply to another, right? But again, I'd say the tried and true way is definitely the cardboard method. We also went over a little bit of how to scale something, obviously through that measurement first, and learning that we make all models in the digital realm 1:1. I can't express that enough. I can't tell you how many times I have students go, "Sir, I accidentally made this 1/4 scale model," and I go, "I can't really help you because I don't know how accurate you made that model," right? Don't get me wrong, you may have made it 1/4 scale, but again, it will need to be scaled. Either way, we'll start here for part 2 next time. Any questions, guys? So far, so good? Sweet. Hey.